Welcome to the Interval 0 video on navigating monitoring session data in Tracealyzer for RTX64. In this video, we introduce key components of the Tracealyzer user interface and discuss a few tips and tricks for finding the monitoring session data that interests you most. Tracealyzer is a diagnostic tool that provides a visual representation of the events that occur during a monitoring session generated by the RTX64 monitor utility. See the Overview of Monitoring in Tracealyzer video for a high-level look at this workflow. Tracealyzer provides more than 30 views of application behavior, including scheduling and timing, interrupts, and interaction between threads and user events generated from your application. You can access the most frequently used views from the navigation bar, the vertical icon bar located at the left edge of the Tracealyzer UI by default. The default Tracealyzer layout includes the trace view, event log, CPU load graphs, user event signal plot, selection details, and filter panels as shown. You can add, remove, and reorder views to create a custom layout that works for you. You can save and recall custom views through the Layout menu. Here we've created our own custom layout that includes the trace view and event log, filter panel, CPU load graphs, and selection and instance details panels, in that order. We've hidden the user event signal plot view since that view is only useful when the monitoring session data includes custom events created by Real-Time API RT_generate_event, and ours does not. For this video, we've created a simple application that spawns two threads. We'll take a closer look at the code and Tracealyzer's rendering of the corresponding events in the monitoring output later in this video. When a monitoring session file is opened, Tracealyzer displays the full high-level view of the session in the trace view. Trace view displays all recorded information on either a vertical or horizontal timeline. Each core has its own timeline. Cores on which there is no activity do not appear. The initial high-level trace view is typically too broad to provide a useful view of the data you're interested in. You can use Tracealyzer's zooming and navigation options to target a specific area of the session data to analyze. First, we want to make sure the entire session is visible. To do this, right-click and select Zoom Out, Show Full Trace. Now we can see the complete picture of the application's activity. The zoom level will determine how many events are shown in the trace view. There are several ways you can zoom in and out of the display. You can use the Control key plus the mouse wheel or the zoom icons in the trace view toolbar to target specific session activity. Here we'll zoom in until we can see the interesting thread activity from our sample application. Tracealyzer uses two key concepts: actors and actor instances. An actor is a thread. Actors are represented by vertical bars of varying colors based on thread priority. An actor instance is an execution of an actor. This is the set of all fragments connected by the same colored band. It represents a single execution of the task which the thread performs. The filter panel provides valuable information on objects in the session output, such as threads and events, and allows you to toggle display of those objects in the trace view. In our custom layout, we've moved the filter panel next to the trace view. This makes it easier to see how filtering objects such as actors and events changes the display of the session output in the trace view. Typically, the first thing you'll want to do in the filter panel is choose which actors to display. Our sample application RTSS_up2 consists of 3 threads. Since we're only concerned with the actors that correspond to the threads in our application, we can turn off all other actors to simplify the view. Under System, we'll turn off all but the idle thread. The idle thread shows gaps in an application's activity, which can be useful in analyzing application behavior. If you're not familiar with the events collected by RTX64 monitoring, you can expand the Services and Notice Channels branches in the filter tree to see a listing of the different events and event groups. For each event, Tracealyzer displays the number of instances the event occurs in the monitoring session output, which can give you a better idea of what to look for. The Process group under Services contains the events that start a process. This information can provide you with a big picture view of your application's activity. By default, all objects but raw data events are turned on in the filter panel. This can add a lot of noise to the trace view and make it harder to locate the application activity you want to see. You'll want to turn off any objects that do not relate to the activity you want to focus on. Click on an object in the filter tree to toggle its display in trace view. For this video, we've filtered out most of the events in the services branch, leaving on only the events that correspond with the important thread activity in our sampler application. We can now see those event labels in trace view. The more objects you filter out, the less zooming you will need to do to see event labels. For example, if we were to show all mutex objects, the number of events would multiply such that we would need to zoom in on the trace view for our event labels to reappear. If we hide the mutex events again, the event labels reappear without having to zoom in. If we look at the code for our sample application side by side with trace view, we can map sections of the code to the events in the monitoring output to see how Tracealyzer displays them. Our sample application consists of 3 threads, known as actors in Tracealyzer. The main thread, displayed as actor T107, thread A, displayed as actor T108, and thread B, displayed as actor T109. The T value in each actor label, such as T109, is the thread ID of the thread. In our code, main thread spawns thread A, which begins to execute. Main thread then spawns thread B, which also begins to execute. Thread A then waits on an event set by thread B. This is the blocking RTWaitForSingleObject event instance shown here. Once that event is set, the RTSetEvent instance shown here, thread A resumes as indicated by the green RTWaitForSingleObject event instance. If you want to know the time delta between 2 events in trace view, such as the time between the blocking RTWaitForSingleObject event and the waking RTWaitForSingleObject event that causes thread A to resume, click on the first event and then press Shift and click on the second event. The precise delta is displayed between the 2 events as shown. Note that the same value is displayed in the event label for the waking RTWaitForSingleObject event. Tracealyzer's event log view displays a textual representation of every event in the monitoring session. To filter events, enter the text that corresponds to the event you are looking for and click Apply. For instance, to find the event set by thread B in our sample application, I would search for wake thread A. To locate a particular event instance in trace view, click on the event in the event log and switch back to trace view. The event you selected in the event log is highlighted. In the filter panel, you can double-click an event to find it in the event log. The CPU load graphs view displays CPU usage over time per actor and in total. All Tracealyzer views connected to the part of the session currently displayed are synchronized by default, which means all open views will update automatically as one view is changed. For example, scrolling the CPU load graphs will cause the trace view display to change accordingly and vice versa. Like the filter panel, CPU load graphs displays a list of the actors in the monitoring session. You can show and hide individual actors by clicking the box to the left of the actor name. At the right of our custom layout, we have the Selection Details and Instance Details panels. The Selection Details window displays information about the currently selected actor in the main view, including details on timing, fragmentation, and any events that have occurred. The Instance Details window displays information specific to a selected actor instance, such as start and end time, execution time, and response time. This concludes our overview of navigating monitoring session data in Tracealyzer. For more information on monitoring and Tracealyzer, see our videos and product documentation available online at interval0.com. Thanks for watching!